Hello guys, we are from Group A4. So our topic is about cooling tower. So before that, I'd like to introduce myself. My name is Kiran Raj with my trick number 211534.
My name is Norman Amirul Benjasni with metric number 211989.
And my name is Amir Anwar, and you can call me Iqbal. And my matrix number is 213132.
So without further ado, let's move on.
Hello and good day everyone, my name is Thank you Solo. My metric number is 211948. Now I'm going to talk about the safety for the cooling tower experiment in group A4. So now before we start the experiment, we usually have to wear our lab coat, and at the same time we have to use a closed used shoe. In other words, you should not use sandals during experiments. Stay focused and aware of the surroundings. In this case, in our cooling tower experiment, we do not use chemicals, so therefore goggles and be careful for chemicals is unnecessary. So moving on to the next slide, we have during the experiment we have to test the equipment, check the manometer level, orifice, float valve, vent bulb, thermometer, so that they operate in the optimized operating mode. So and later on we have to check the leakage in the piping systems, and also we have to make sure the reading equipment works accordingly. Make sure to follow the procedures based on the lab report. So after the experiment, we have to make sure we clean and wipe dirt and the water after using the experimental equipment, and then we have to check for damages on the equipment, checking the hose, the wiring, and the overall equipment. And then at the end, we have to switch off the main power before leaving to avoid any power surge, power usage. So that's all for us for safety. Thank you.
Okay, so let's move on to the apparatus. So first here we have our cooling tower. So basically the working principle of cooling tower is like a heat exchanger where we have two different medium, which is air and water, which mix together, and basically that's where the heat exchange is going to happen. So the first one is the fan. We have our fan over here. So the fan, we have a damper. This is where we regulate how much air is going to enter the fan. So basically the fan is going to suck the air and it's going to pull. It's going to blow through the cooling tower from bottom to the top. So next we have our main switch, our 0.5 kilowatt switch, and our 1 kilowatt switch. This is basically our load where our water, which we're going to pour at the makeup tank, is basically going to go through a heater, and the heater load is selected over here. So the higher the kilowatt is, the even hotter the water going to be. So then we have our airflow manometer. So the function of the airflow manometer is basically it shows at what pressure is the airflow is. So nextly we have our cooling water flow meter. So the purpose of this cooling water flow meter is actually we can actually regulate the flow of water which is going through the cooling tower. So this is the main tower. So the tower basically is designed how the water is going to flow from the top to the bottom. Meanwhile, the air is going to go from the bottom to air. So you can see here at the tower we have a lot of rays of like cardboard. It's actually not a cardboard. It's actually a wood. So the purpose of the wood is actually to slow down the flow of water. So basically, imagine if there's a water is going in, the water is going to go through each and every row of this wood. It will slow down the water. So that is the purpose of this packing. So while it's going down, the water is going down the cooling tower, the air which we're going to regulate through the damper over here is going to blow. So which where the heat exchange is going to occur. So I think that's pretty much it. I have explained about the basic principles and the apparatus about the cooling tower. That's all from me. Thank you.
Okay, next we are going to the methodology. We want to start the procedure. So this is the pre-experiment, which is before commencing the experiment. Ensure that all the valves and switch are in desired position. So firstly, the orifice differential must be 16 mm H2O, and water flow rate must be 40 gm per second, and then the cooling load is 1 kilowatt. Okay, after that we set up the apparatus properly and ensure that there are no air traps in the pump. Check the manometer level first, orifice, float valve, wet bulb thermometer, so that they operate in their optimized operating mode. Ensure that the unit is ready for use before set to the desired condition. So take note all the temperature and flow rates will at the desired time interval. Determine the quantity of makeup water which has been supplied to the makeup tank within the time interval. So repeat the experiment with other water or air flow rates with another load. So the other we repeat the experiment with other setup, which is we can use 1.5 kilowatt. So we switch on the 1 kilowatt and 0.5 kilowatt, so that it will be 1.5 kilowatt, and then we can change the water flow rate, which is we go to 30 or 50 or 20. Then the orifice differential, we can go to 15 mm H2O and 25 mm H2O. So we can choose the setup that we want. Okay.
Okay, for the results of this cooling tower experiment, by using the psychrometric chart, we can determine the enthalpy, humidity ratio, and the specific volume of the air at outlet and inlet. Second thing is we can investigate the dry air mass flow rate, which is MA, and the rate of makeup quantity, which is ME, and the specific enthalpy of the makeup water. And lastly, we can determine the pump power and mass balance for the system. And then we plot the graph for the temperature versus cooling load for both watering entering tower, which is the inlet and the outlet. That's all from me. Thank you.
Hello everyone. Now just continue to the results. So first objective was using the psychrometric chart. We have to determine the enthalpy, humidity ratio, and also the specific volume at point A and B. Next, we obtain the dry mass flow rate, the rate of makeup and makeup quantity, and then we find the specific enthalpy. So finally, we also have to determine the pump power and also the mass balance for the system. So here we have the psychrometric chart that we are using to find the necessary values to relatively the humidity ratio. So next we are just showing the tables, the necessary tables, the orifice differential, and then we have the dry and wet bulb at stage A and point A, and then we have point B, and then we have the dry air mass flow rate and so on for at table 4, and then we have table 5 for the pump power and balance of the system, and table 6 for cooling range. So objective 2 is plotting the graph for the temperature of the cooling load for both water entering tower and water leaving. So the expected results shown in the graph is increasing linearly. So the fixed provided heat in the load tank, which results in the consistent temperature of the water entering, reduces the range of inefficiency when the water flow rate is increased. So as a consequence, the temperature of the water leaving will rise and resulting in a reduced cooling range and efficiency. So that's all from our group A4. We just conclude our video now.